Question number 12. This question is from circles. The diagram shows a circle P with center 0, 2. This is circle P. This will be the center of the circle and radius 10. Center of the circle P is 0, 2 and radius 10, and the tangent to the circle at point A with coordinate 6, 10. It also shows a second circle Q. This circle is circle Q. This circle is circle P. This is the tangent at A on the circle P. It also shows that second circle Q with center at the point where this tangent meets the y-axis and with radius 5 over 2 and into under root 5. This is the radius of the circle Q. And this is the center of the circle Q, because it is given. It also shows a second circle Q with center at the point where this tangent meets the y-axis. This line is a tangent and this meets the y-axis at this point. This is the center of the circle Q, and radius of the circle Q is 5 over 2 under root 5. Write down the equation of circle P. To write the equation of circle, we need the center of the circle and the radius of the circle. Center of the circle P is 0, 2 and radius is 10. So let this point is the center of the circle P. It is coordinates are 0, 2. We represent this point by C1. 0, 2 are the coordinate of this center of the circle, or this is the radius. This is the radius of the circle P, that is 10 units, 10 cm. Or this line, this angle will be a right angle, because radian and tangent makes always a right angle. This angle will be, this is the tangent, this is the radius, this angle will be 90 degree. So the coordinates of this point A are also given. 6, 10, coordinate of point A, 6, 10. Now we have the center of the circle and the radius is also given. Now we can find the write the equation of circle P. Center is 0, 2 and radius is 10. This is the equation of the circle. Equation of circle is x minus a whole square. This is the general equation of the circle having center AB and radius R, plus y minus b whole square is equal to R square. This is the general equation of the circle. So here A, B shows the center of the circle and R is the radius of the circle. But in the question, center is 0, 2, radius is 10. Putting here the values, we get equation of circle will be x minus 0 whole square plus y minus 2 whole square, radius is 10, we can write 10 square. So simplifying it, we get x square plus y minus 2 whole square is equal to 100. This is the equation of the circle P. Now next part of this question is find the equation of tangent to the circle P at point A. Tangent to the circle at P. This is circle P. This is the tangent at point A. Coordinates of A point are given 6, 10. We have to find the equation of this tangent. To find the equation of the tangent, we need the point, or clearly we have this point, but also we need a gradient of this tangent. So since this line, this radius is perpendicular to the tangent, first we find the radius of this AC dash, AC1. We will find the radius of this, we will find the gradient of this line, that is the radius of the circle P. So points are given, we can find the gradient of this line. Then we can find the gradient of the tangent, because tangent and this line are perpendicular to each other. So first we find the gradient of this line, that is the radius of the circle P. So gradient of radius, gradient of radius, that is AC1, that will be 10 minus 2 over x, y2 minus y1 over x2 minus x1. So we get the gradient is 4 over 3. This is the gradient of the radius. But actually we need the gradient of this tangent, because we have to find the equation of this tangent. Tangent line is perpendicular to this, so gradient will be the negative reciprocal of 4 over 3. So gradient of tangent at A will be negative reciprocal of 4 over 3, that will be negative 3 over 4. Now point equation point is also given, that is 6, 10. So equation of this tangent at A will be, equation of tangent will be y minus 10 is equal to gradient negative 3 over 4 x minus 6. So now we will simplify it by cross multiplying 4 into y minus 10 and 3 into 1. So we get 4, 4y minus 40 is equal to minus 3x plus 18. Further simplifying, we get 3x plus 4y is equal to 58. 3x plus 4y is equal to 58. This is the equation of the tangent at A. The next part of this question is part C. Find the equation of circle Q. Find the equation of circle Q. First we will find the equation of the circle Q. This is the center of the circle and radius is given. Radius of circle Q is 5 over 2 under root 5. So we can write that the center of the circle Q is C2 and the radius of the circle is 5 under root 5 over 2. This is the radius of circle Q and C2 shows the center of the circle Q. Actually, we have to find the equation of this circle Q. We need radius, which is given, that is 5 under root 5 over 2, but we need coordinates of the center of circle Q. So, since this point lies on this center of the circle lies on the y-axis and also this point lies on the tangent. But on y-axis, the value of coordinate value of x will be 0. So putting x is equal to 0 in the in the equation of line of tangent equation of tangent we have already found. In this tangent equation, we will put x is equal to 0. We get this point. That is the center of the circle Q. So equation of tangent is 3x plus 4y is equal to 58. Now, since this tangent passes through y-axis, so x is equal to 0. Putting x is equal to 0, we get the center of the circle Q. As x is equal to 0, this shows, putting this value of x here, we get 0 plus 4, y is equal to 58. From here, y is equal to 58. 58 over 4, that is 29 over 2. 29 over 2. So coordinates of the center of the circle Q2 will be 0, 29 over 2. We can write here coordinate of a center C2 29 0 20 x is equal to 0, y is equal to 29 over 2. Now we can find the equation of this circle Q2 because we have radius and a coordinate of the center of the circle Q. We can find the equation. The point center is 0, 29 over 2. Now equation of circle Q. Equation of circle Q, x minus 0, using equation of circle, x minus 0 whole square plus y minus 29 over 2 whole square is equal to radius square. Radius is 5 under root 5 over 2, and there will be a square. This is the equation of the circle Q. Now, and hence verify that y coordinates of both the points of intersection of the two circles are 11. Y coordinate point of intersection, y coordinate of both the points of intersections intersection of two circles are 11. These are the point of intersection of the two circles. This is the point of intersection of the both the circles. This is also the point of intersection of both the circles. We have to verify this point. Y coordinate for both these points is 11. So to find the point of intersection, we solve the equation of both the circles simultaneously. So simplifying it, first we simplify it, we get x square plus y minus 29 over 2 square is equal to, simplifying this, 5 under root 5 over 2 whole square, we get here 125 over 4. This is the equation of circle Q. Now we have to find the point of intersection of both the circles. So equation of circle Q1 we have already found, that is x square plus y minus 2 whole square is equal to 100. So we write this equation of the circle here. This is the equation of circle Q. This is the equation of circle Q, and we are writing here the equation of circle P. Equation of circle P is x square plus y minus 2 whole square is equal to 100. Now we will solve these two equations of circle simultaneously. Now by elimination method, we are subtracting both the equations. We will change the sign of the lower terms, cancel out. We get y minus 29 over 2 whole square minus y minus 2 whole square is equal to, now we will subtract 125 over 4 minus 100. After simplifying it, we get minus 275 over 4, minus 275 over 4. Subtracting these, we get minus 275 over 4. Now expanding these, we get, now we will use identity here, squaring y square plus a square plus b square minus 2ab plus 841 over 4 minus 29 y minus, now expanding this y minus 2 whole square, this will become y square plus 4 minus 4y is equal to minus 275 over 4. Now this negative sign will change the sign of the terms inside the bracket. We get y square plus 81 over 4 y square plus 841 over 4 minus 29y minus y square minus 4 minus plus 4y is equal to minus 275 over 4. These terms are cancelled out. Y square minus y square cancel out. Or now simplifying remaining terms, 841 over 4 minus 4 and minus 29y plus 4y. Finally, we get minus 25 by simplifying this. You can simplify these terms, minus plus 841 over 4 minus 4 and minus 29y and 4y is equal to this. Finally, after simplifying, we get minus 25y is equal to 275. From here, y is equal to 11. This is shown. In your rough work, you can simplify these two terms because I have left this step. Finally, we get y is equal to 18. After simplifying these terms, we get this equation. From here, we can find the value of y, that is 11. So, y coordinate of both the points of intersection of the two circles are 11. So last part of this question is part D. Find the coordinates of the points of intersection of the tangent and the circle Q, giving the answers in the third form. Third form means not in decimal places or significant figures. We have to give the answer in under root form. Intersection of, we have to find the intersection points of intersection of tangent and the circle Q. This is the tangent. This line is a tangent and this is the point of intersection of the line, a tangent line and circle Q. We have to find the coordinates of these point of intersection. So in this question we also use the same process simultaneously, solving of equation of the line of tangent and the equation of the circle Q. So equation of tangent is, already we have found equation of tangent, that is 3x plus 4y is equal to 58. This is the equation of tangent. Let this equation is equation number 1. Now equation of circle Q, equation of circle q, that is x square plus y minus 29 over 2 square is equal to 125 over 4. Let this equation is equation number 2 for reference. Equation of circle cube we have already found. Equation of circle cube is this. Now we have to find the point of intersection of tangent and the equation of circle cube. So we are using here the substitution method for solving. First of all, we are making a subject of any variable from here. So we are making y the subject from equation number 1. From equation number 1, we are making y the subject. From equation number 1, from equation 1, y is equal to 58 minus 3x over 4. Now we will put this value of y in the above equation of the circle cube. We get x square plus 58 minus 3x over 4. We are putting this value of y in the above equation, equation of circle cube. 58 minus 3x over 4 minus 29 over 2 whole square is equal to 125 over 4. Now we will simplify it. Taking LCM of inside the bracket, there are two fractions. We are taking LCM of inside the bracket, x square plus 58 minus 3x minus 58 over 4 whole square is equal to 125 over 4. These two terms are cancelled out because of opposite sign. The remaining we get x square plus there is only remaining term minus 3x, but whole square, also there is whole square, minus 3x over 4 whole square, that is 9x square over 16. We are writing here 9x square over 16 is equal to 125 over 4, 125 over 4. Now adding these two terms, we get 25 over 16 by taking LCM. We are adding these two terms, x square over 1 LCM is 16. We can write by adding these two terms, these two fractions, we get 25 over 16 x square is equal to 125 over 4. Now further simplifying, we get x square is equal to 125 over 4 into 16 over 25. Simplifying, we get two values of, these are cancel out, 25 5s are and 4 4s are, so x square is equal to uh, x square is equal to 20 x square is equal to 20, and taking square root each side we get x is equal to plus minus, x is equal to plus minus 2 under root 5. These are two values of x, or by putting in the above equation, here we get two values of y. So when x is equal to positive 2 under root 5, so we get y is equal to, putting here the value of, we will put this value of x here, we can get this value of y is equal to 29 minus 3 under root 5 over 2. And also when x is negative 2 under root 5, we get y is equal to, putting here the value of x again, putting here the value of x, we get y is equal to 29 plus 3 under root 5 over 2. So these are 2 points of intersection. Now writing in point form, we get 2 point of intersection of the tangent and the circle Q. This is the point of intersection. And the other point of intersection is minus 2 under root 5, 29 plus 3 under root 5 over 2. So these are the final answers. These are 2 point of intersections. These are 2 point of intersection of the tangent line and coordinates of the points of intersection of the tangent and the circle Q. Answer is clearly given in third form.